Hey guys, welcome back to Rocket Gyan, my fellow space tubers. And today we are going straight to Japan to witness another launch, and this time is the H3 rocket. This one is a special one because, well, people are waiting to see if H3 is becoming operational or not, because H3 rocket is a game changer, literally a game changer for Japan. And just a second. Yeah. So H3 is literally a game changer for Japan because it's literally cutting down the cost of the rocket, cost per launch of the rocket, from around $110 million to $50 million. Whoa! And without even uh, compromising with the payload capacity that much. So that's why this is the rocket which is going to be the workhorse for the JAXA space agency. And we will see what this rocket is all about, everything regarding this. And well, let's just jump into it. Hi Wildflower, hi Harsh, and Robster. Welcome to the stream. Hi Jennifer. Yes, we are here. Everyone is here. I hope it's good morning time in my country, 7 a.m. around here. I think in US it's around 11 p.m. So good night time for some people, some folks, right? No worries. We'll see the launch and then we'll go for a good night. It's okay. So this is the rocket in front of you, and this is a special one. We'll talk about the characteristics of the rocket, what this rocket is all about, and payload capacity and whatnot. But this is a signature of the Japan and the JAXA, because you can see the orange foam all over it, right? No matter how many rockets they make from Japan, they always have this signature foam running all around the rocket, which signifies that it's using cryofuels, and not only cryofuels but liquid hydrogen and liquid oxygen. So that is clear from this. And also you can see one thing from here, that the rocket is actually placed inside the launch pedestal. It looks like that, right? Because it literally is placed like that. So H3 rocket is kind of the biggest rocket in terms of height which the Japan has produced. And just a second. Yeah, H3 rocket is the biggest in size which the Japan has produced. So they are using the already the launch stand, launch pedestal, or whatever, you launch pad, uh, which they developed for the other rockets, the H2A rockets and all those things. So that's why you can see it's inside that launch pad. And because obviously they had to compensate somehow, so they made sure it's inside the launch pedestal. So that's something. Hey Benjamin Hall, 643 in Seattle. Okay, nice. We have some ranging. Yeah, obviously our audience is international, so sorry, timings will also be international. So let's talk about this rocket now. So this rocket is having these many configurations which will be seen. So today's mission will be from in this one, the SC22S. We'll talk about the other all these configuration also. So first of all, this mission was supposed to fly on H330S, but then they decided to fly it on H322S. And all these configurations differ in terms of how much payload it can take to the orbit. And so let's talk about the naming convention. So S simply means the the fairing, the size of the fairing. S means small fairing, L means large fairing, which you can see almost double the size of the small fairing. And 3, the first 3 here signifies the 3 LE9 engines, which we will see here. So the first stage has those, and 0 means this, for the second number signifies the number of SRB boosters. So in SC22S, which is flying today, we'll have 2 LE9 engines and 2 SRBs, which will be going. Similarly, the heaviest configuration will be HC24L. They also had the plans for H332 S and L, but I think they dropped it in between. So there's that. 32 means 3 LE9 engines, 2 SRB, more payload to the low Earth orbit and GTO. So yeah, that is the case. And talking about the payload capacity, the max it can take is around 7.9 tons to geosynchronous transfer orbit, and around 4, yeah, payload to sun synchronous orbit is also around that 4 tons. 4 tons will be the payload to the sun synchronous orbit. Yeah, so we will talk about. Hi, Remiji. I hope you are doing good. Yes, I do remember you. You are a regular person. And we have G also, and 9:44 in New York City. So people are actually watching it during the night, which is great, because usually people are at that time dinner. They have eaten the dinner and getting ready to bed. So nice bedtime stream, right? Cool. So okay, next thing. So let's talk about the rocket itself. We have this is the rocket. We will talk about the engine. So in this rocket's speciality lies in its engine. So this is the world's first rocket in which the expander cycle is being used in the first stage engine. And you might be wondering, I mean, first of all, I'll talk about what expander cycle is, but you might be wondering why only this was, the Japanese engineers were capable enough to design a rocket which was using expander cycle. We'll talk about that also, but yeah, this is the one thing which separates it apart. So we have the first stage engines, the LE9 engine, the SRBs. Then we'll talk about those engines in detail. Then we have the fuel tank, and it stores liquid hydrogen, liquid oxygen as its fuel. This is the first stage. The second stage is again this is the LE53B engine, which is the third iteration of the LE5 engine family, and this also runs on the expander cycle. So here you can see the gas jet system, which is nothing but the thrusters, the roll control thrusters and RCS thrusters, whatever you want to say. Yes, this also runs on liquid hydrogen, liquid oxygen as its fuel. You can see it's around 63 meters in length, 5.2 meters in diameters, which is kind of around 5.2 meters or something. Is cool, is very cool. And you can see the first stage engine produces around 1472 kilonewtons per unit thrust, which means more the number of engines, more you can multiply it accordingly. Then we have the second stage engine producing 137 kilonewtons of thrust, and SRB is producing the holy grail of thrust, around 2158 kilonewtons per unit. So this is the thing, and they moved from H2 families to H3 families because of the high cost performance, high reliability and high flexibility. But the main thing was the high cost performance, because there right now the launch vehicle which they had was the H2A, and it costed around $110 million per launch. This they reduced it to around $50 million per launch without reusability, which is at par with the SpaceX Falcon 9. Right? But obviously Falcon 9 can take a lot more to space, to orbit. But again, it's kind of like industry standard if it's able to bring down the cost by half. So yeah, so there's it. That was the overview of the rocket. Now let's just see the the unique thing about this rocket, the LE9 engine and the expander cycle. So this is the expander cycle, which you can see. The expander cycle, what happens in expander cycles, there is no auxiliary combustion chamber, which means there is no pre-burner to it. The fuel pump, you can see the fuel is fed directly to the combustion chamber and then to the nozzle, which is where the heating actually happens. And you can see all the heat exchanging happens over here, which means the liquid hydrogen fuel turns into gas, which is then pumped into the turbine. This turbine in turn turns these all turbo pumps of the fuel and oxidizer, and then the fuel which has turned the turbine is again fed into the combustion chamber. And the oxidizer pump, you can see it is directly connected to the combustion chamber. So only the fuel, which is the liquid hydrogen, which flows around the engine. And you might be wondering why liquid hydrogen and not the oxygen. Well, if you are here in this channel from beginning, you must be knowing this, that liquid hydrogen and liquid oxygen, the preference is given to liquid hydrogen because first of all it's non-corrosive, second it's easier to handle, it's not that kind, main is non-corrosive, that is the case. It's not like the liquid oxygen, it's more combustible, because oxygen is kind of combustible in the case, like it makes sure that whatever is burning burns violently, but it itself is not like highly flammable. So but liquid hydrogen is, so that's why they need to have those rofies. If you will see it, but I'm not sure, since the launch the rocket itself is inside the launch pedestal, so we might not see that, but there will be some rofies, which is radially outward firing igniters, running in just before the ignition to mitigate all those hydrogen buildup, which you see in the Delta for heavy liftoff also. So that is some of the characteristics, and space shuttle also. So that is some of the characteristics of the LOX, Hydrolox engine. So this is the LE9 engine, you can see. Okay, so I was talking about the expander cycle. So the expander cycle itself, why people have not used it in the first stage itself, because in the expander cycle the issue is that, as you can see, there was no the auxiliary turbo pump or the pre-burner, right? So because of that, there is a limit on how much you can produce, how much pressure you can generate to run run the turbines, and it is actually limited by something called a square cube law, which is nothing but it kind of describes the relationship between the volume and the surface area as the shape size increases or decreases. So basically what it means is, the issue is in this kind of an engine is that liquid hydrogen, when it is pumped through the nozzle and the combustion chamber, it has its own surface area, right? You want to pump in more liquid hydrogen to generate more thrust and all those things, but how fast that liquid hydrogen can consume the heat which is being developed in the engine and turn itself into gas is limited. It's kind of that is the limited, the square cube law, which is not, it's not that totally directly proportional to if you increase the size, you can also increase the coolant lines like that. It does not directly go scale up like that. So we have a limitation on that, but somehow the Japanese engineers have figured out a way and made this engine like this, and they deliberately used this cycle because they wanted to make sure this engine is very easier to produce, and they can also use 3D printing over it. And yes, they are using additive manufacturing to make those components of this engine. So all these things were kept into mind to make sure the cost is less, it is highly producible, and the turnover time is, you know, the production time is less. So that's why we have this engine, and it's not an open cycle engine, it's a closed cycle engine. But somehow they figured out a way to make sure it produces a lot of thrust. So kudos to the Japanese engineers. So I really wanted to show you one video which shows you the startup sequence of this engine. So we have the ignition in the igniter chambers, that was the injection coil, and then we have the combustion chamber. You can see the valve is opening here, cooling chamber valve opens here, then the oxygen, the turbo pump start, which means the tank pressure is somehow, first of all, the rotates these turbo pumps, and then it is produced, and then the fuel, the oxidizer valve is also open from here, the oxygen also flows. You can see, first of all, the liquid fuel pump is valve is open because that has to flow a lot first, then the oxidizer will come into picture, that's why. And after that it is heated into this combustion chamber and the nozzle, and then it fed indirectly again into the turbines, which is in middle somewhere, which kind of rotates the turbo pumps again. Or maybe they may not be using even the turbines. I'll have to look at the schematic diagram of this, because sometimes they use the turbine, sometimes they just pump it directly to the turbo pumps, so they don't even need it. So it depends, we'll have to see. Okay, that's how it is. You can see it like that. I think this is, yeah, if they are not using the turbines, I think okay, this is not a proper closed cycle engine. You can see some of the gases coming out of here, which means they are not employing turbines here. They are directly pushing it to the turbo pumps, and then whatever um, the fuel which they used, they are just dumping it out, kind of like that. So somehow they make sure they must have played with some of the trade-offs to make sure what all things they can do, and not, you know, to increase the thrust, but also make sure the efficiency is there. So yeah, now let's talk about the satellite which is going, which is known as the DAICHI-4 or the ALOS-4, which is nothing but a SAR satellite. So ALOS-4, so it's a hybrid kind of, you can say that. It's actually, you know, very, this is one of a kind of engine which no one has produced. So usually what happens in expander cycles, we have a turbine which is rotated, which in turn rotates the turbo pump, which I showed you in the diagram. But I don't think so they have turbine. They're directly pumping it to the turbo pumps, and then they're just dumping it out. Maybe that hydrogen which they are dumping it out might not be that energetic to be you know, dumped into the combustion chamber. We just don't know. So there might be some trade-offs with the thrust and all, so let's see. I'm not sure. In that case, I'll have to do some more digging, which I'll do in the next launch, because that also I just saw that they are dumping it out, so we'll have to see. Okay, so yeah, this is a SAR satellite, the L-band radar technology which is being used here. So they will so unlike observation by an optical sensor, which we all know, the SAR satellites can acquire day and night, as it does not require any sunlight, because it uses the radio waves. So there's that. This is the ALOS-4 satellite, and this will be equipped with the automatic identification system for ships, which so that the satellite will also monitor oceans by receiving AIS signals from vessels, as well as by acquiring the PAL SAR-3 images. So this will also not only be a SAR satellite, but also an ocean monitoring satellite. It will aid all the fishermen, the sailors, and all those navy people also. So it will be, and Previously they launched the Daichi-2 satellite. Now they have launched a Daichi-4 satellite, which has the same resolution but a bigger swath width, which makes sure it is able to cover more ground in one scrape only. uh, and it has a shelf life of 7 years. The mass is around 3 tons. It's going to sun synchronous orbit, and it has the, yeah, not so sure about the propulsion system on this, but yeah, this is the satellite which we have. So I have one video for you. I don't think so I'll be able to play it, but what I wanted to you to see is that there is antenna deployment. First antenna deployment, SAR 3. This is the SAR antenna deployment which happened. Then we have the Space 3 antenna deployment, which will aid for that ocean thing. And this is how it will look like when it is fully deployed. So yeah. Now they will also be testing the throttling of the first stage. So the mission profile will look like this. In this case, the liftoff, the first, then the SRBs will separate, the fairings will separate, the first stage engine throttling, they'll test it out. After that, the MECO will happen, the main engine, the first stage cutoff, then the separation of first stage, second stage will happen, then the second stage engine will ignite, then it will stop. The Daichi-4, which is the ALOS-4, will separate. The second stage engine will reverse its orientation. Then it will again ignite its engine to deorbit, and then finally there will be a controlled fall into the Indian Ocean. So there will be, as you can see, the throttling will be done. Thrust is reduced to approximately 66% for this one, but they plan to reduce it to 63% also. I think no, they will be reducing it to 63% right now. Then they will be reducing it to 66% in the next flight, because they had some issues with the first flight. So yeah, let me see if we have the. Yep. Yeah.
Including emergency observation in case of the disaster across Japan, and we believe that it has significant meaning to send a successor vehicle, Daichi-4. So we'd like to talk about the overview of this vehicle.
So I'm sorry for you must not be able to hear them, but they were discussing about how they were able to make sure that this will be the first operational flight of the H3 rocket. Now they'll be telling us about the H3 rocket itself.
I'd like to talk about that aspect. So the very bottom, there is LE9 engine, which has 2 of them, and to the both sides there are 2 SRB3 boosters. And these two, because they have 2 on the both sides, so we are called these 2. And the last portion S is the fairing is the short version, so that is the S coming from. And the H3, other than this 2-4 form or 3-0 form that we call, for example, SRB3 in case 4, then 2-4, and SRB without them, and and LE9 engine 3, then 3.0. And I'd like to talk about the overview of the rocket. So to understand the most important point to understand the rocket, the launching vehicle, it's actually the transportation vehicle. Last time I mentioned about the delivery service. So what they carry is to carry the things in this white portion. So we have the ALOS-4. Below is actually to have the swath and also other the drivers. So the orange is actually the tank that contains liquid hydrogen and the liquid oxygen as a fuel. And using these fuel and this LE5B3 engine and these engines, we supply the energy power. And the booster here, SLB3 here, and the LE9 that we use. So the total weight is around 420. So that is actually to drive the power, and also using the two engines to put into the orbit. So we carry the cargo doing so. And thank you very much. So this H3 the launch vehicle, is there any difference? Basically, it's the same. So the shape is the same.
And slightly difference is that we were having a dummy satellite before, so it was separated at different time from the original separation timing for safety reason. But this time, ALOS-4 will be separated as usual after the second stage cutoff. So there's a difference in procedure. Okay, and H3 rocket was designed to achieve high level of flexibility, reliability, and low cost. Is there any strength to the...
They have copied ISRO's presentation, right?
Well, as you might know from the TV programs, a launch vehicle business has become a fiercely competitive market with private companies now developing their own. So-called rocket business?
So, yes, obviously they have to make sure the cost was down in this case. That's why they developed the whole purpose of H3 to be here and to replace the already proven and reliable H2A rocket was the cost. Literally the cost and the production time of the rocket, because they had to compete with the overall market, and it was very, very costly for them to manufacture all that. They commercialized many of the parts. They had private partners making some of the parts. So previously they were making all in-house. So that was one of the change, and they make sure all the things and all the production things, manufacturing process is simplified so that the low cost is there, as well as the production time is not that high.
Yes. Well,
And we have the rocket on the pad. You can see, literally you can see this one. It's like, on the launch pad, the rocket itself is kind of inserted, right? It's like that. And there because this is a longer rocket than the H2A was, and they had to make sure they will be using the same pedestal, the launch pad. So they had to make some modification, and one was to use to make the rocket go inside the launch pad.
Jibo Cannon in Aizu Wakamatsu is 57 meters long. Well, it's a good point. I think the Cannon statue wearing a mask during the pandemic is the one that you're talking about. I think our audience might notice and recognize it, but I hope so. Thank you very much for your explanation about the H3. Aiming for further evolution, the H3 project team has been renewed this spring. I interviewed Mr. Makoto Arita, new project manager since April, about his thought on the future of the H3.
もともと岡田プロマネの下でサブマネージャーをやってました。ですから。
So, the thing which they'll not talk about is how this rocket this rocket got delayed for so many years, literally so many years, but finally they were able to pull it out. They were able to make sure that the rocket which they are using is reliable, because the first launch was not successful. The LE5 3B engine, the second stage, which is the third update on the LE5 engine which they made on this for this rocket, did not start up for the first flight, and the second flight was successful. But again, now that was also a development flight, but since it was successful and they got confidence that yes, everything went perfectly, they made this one the first operational launch. And yes, S322S is the configuration which is launching today. So we'll see what happens today. I am pretty sure Japanese engineers, I trust them, so they should be able to launch it perfectly, but we'll have to wait and see. Although the weather right now is looking very charming, does not look like it's cloudy enough over there, so it should not be a problem. So yeah, let's see. So talking about Jennifer, yeah, so if they did not paint logos and all, to be honest, it does not actually require that much of paint job. Some of the rockets does not even do that. Like the H3 rocket itself, it has minimal paint job. All of the rocket is covered by that orange foam. So there is that, and then there is Firefly also, which is like the holy grail of paint jobs. Sorry. But the thing is that they have their own criteria running behind. So if they feel like the paint is having some great amount of payload reduction, which does not happen usually because paint is not that much heavy, so they usually paint that. So to answer your question, no, they don't have that much of reduction in payload capacity when they actually paint a rocket. So this ULA CEO Tori Bruno himself said that paint job does not cost in terms of payload that much, so they can go ahead and paint all those funky logos, funky paint jobs and all those things. Even I remember one of those times when I think there was some branding, the advertisement which was being done on the rockets, because see, we know rockets are being watched by like thousands, millions of people, right, when the launch happens. So why not advertise on rocket? It will also bring down the cost, right? So this is one of those things which I would personally love to see in near future, so that the private companies doing all this, so that the cost of the rocket itself comes down. So let's see if that happens or not.
To be passionate about moving people, and that's what he believes in. So I think really that's really of Arita-san. But anyway, now I would like to introduce the Advanced Land Observing Satellite 4, or ALOS-4, which will be launched today. Please watch this video.
地震や火山の噴火、洪水や浸水被害、森林の減少、海上トラブル、環境にまつわる問題は地球上のあらゆる場所で我々の予測が難しいタイミングで発生します。そのような問題の解決を目指すのが第一シリーズの最新後継機、先進レーダー衛星大地4号です。大地4号は精密な監視で広範囲の情報を迅速に捉えることができる高性能レーダーにより、地球規模の課題解決に貢献します。大地4号は日本が誇る L バンド SAR を搭載したレーダー衛星です。SAR は放射した電波の反射を受信、処理することで画像を得るレーダーです。雨や雲を通り抜け、昼夜天候を問わず観測が可能です。 L バンドは比較的長い波長であるため、地面の情報を得やすいのが特徴です。日本は地震や火山が多く、国土の3分の2が森林で覆われているため、その活用価値は非常に大きいです。問題解決のために性能強化を図ってきた第一シリーズ。第一4号は2006年に打ち上げられた第一、2014年の第一2号に続くレーダー衛星として開発されました。第一4号は先代の第一2号の特徴を引き継ぎつつ、技術開発によりさらなる進化を遂げています。
Yeah, it will be okay.
世界最先端の L バンドサー、パルサー3。第一4号ではデジタルビームフォーミングの導入により、第一2号の航空間分解能を維持しつつ、各観測モードの観測幅を拡大しました。デジタルビームフォーミングとは、アンテナで計測した電波を高速にデジタル処理することで、同時に様々な方向の観測が可能となります。これにより、3メートル高分解能モードでは 200km、広域観測モードでは 700km の観測幅を実現し、広範囲にわたる豪雨被害や大規模地震などの場合においても、被災地を一度に観測できるようになりました。第一4号では第一2号と同様にスポットライトモード、高分解能モード、広域観測モードという3つの観測モードを選択可能です。状況に応じて最適なモードでの L バンドサーによる観測を行います。高性能型の AIS 受信機スパイス3。 AIS とは船舶からさまざまな情報を周辺船舶や陸上局に向けて自動的に送信するシステムです。海上の船舶からの電波を宇宙にある第一4号でも受信します。第一4号に搭載される AIS 受信機では、高度な信号処理技術を採用することで、過去の受信機で課題となった船舶過密域での信号受信率向上が期待されます。光衛星間通信によるデータ中
This
継。
I forgot to tell you.
光衛星間通信システムは、目に見えないレーザー光を用いた宇宙空間での光通信によってデータ伝送速度の高速化を実現します。第一4号で取得した観測データを一旦静止衛星が中継し、地上局に送ることで、軌道1周の約半分の期間データを送ることが可能となります。減災・防災への貢献。第一4号では観測幅を拡大したことにより、日本全土の観測頻度が第一2号の年間4回から年間20回へと大幅に向上します。この高頻度観測によって災害の発生状況をよりタイムリーに検出することができ、早期のリスク評価に役立てられます。第一4号の高頻度に蓄積されたデータを統計的に処理することで、地表の微小な隆起や沈降を捉えることができます。国土地理院と連携して日本全土の地表の変動を定期的に監視し、国家座標の維持管理や地盤沈下調査などへの活用を進めていきます。 L バンドのレーダーは雲、雨、葉、枝を透過して地面や木の幹の状況を捉えることに適しています。広範囲を長期的に観測することにより、世界の森林の増減を把握し、森林管理や気候変動対策への活用に貢献します。第一4号は第一2号のミッションを引き継ぎつつも、民間の小型衛星などと協力して問題解決と先進的なサービスを世界に展開します。持続可能な未来のために、小さな変化も見逃さない、未来の社会に貢献するために、第一4号は可能性を追い求めていきます。
You know what? Whenever I hear Japanese, only one thing comes to my mind, that is anime and their dialogue delivery. That's it. sounds so much like that. I mean, obviously, this is totally different, but that is what comes to my mind. Okay, coming back to this launch. So yes, this satellite is going to use the laser communication with another satellites in geostationary orbit, and that is to allow high data transfer to the ground station when it is in the, because this satellite will be placed in sun synchronous orbit, and sun synchronous orbit is obviously will be changing. The satellite will be around 700 kilometers up, so because of that it won't be able to give the proper data every time to Japan. So that's why if one of these satellite is in the geostationary orbit, half of the orbit will be in range and it will be able to transfer its data to that satellite, and then that satellite can beam it down to the earth. And now you can see how these difference between the SAR radio waves and the normal waves. The radio waves, they don't get scattered at all, though they it does not require any day or to for it to work. It can penetrate through clouds, and the surface is also not that much on the surface it does not scatter. So because of that it is able to get the proper what should I say, the texture of the surface.
Pictures at all. But the later satellite, because it emits a wave of its own and actually permeates the cloud. So even under the cloudy situation, you can actually understand what is on the surface. So the onboard SAR makes such things possible. Yes, of course, there are benefits of optical satellites, but radar satellites works in that way. And of course, there are other satellites with different functions. Could you briefly explain the other types of satellites? Yes, there are many types, but broadly speaking, telecommunication satellite, positioning satellite, and like ALOS-4, we have Earth observation satellites. Now, ALOS-4, or maybe Himawari, that you may know, the meteorological satellite, these are categorized as Earth-observing satellites as well. And telecommunication satellites helps internet and the satellite broadcasting and satellite communication possible. And also positioning satellite, we have a Mitsubishi, which is launched by Japan. So you can understand your location with your cell phone, and that is a benefit of Mitsubishi satellite. And also scientific mission to observe solar situation as well as a magnetic field do exist as well. Thank you. Now, I would like to show you how data from Earth observation satellite ALOS-4, which will be deeply involved in our daily life, will be used in the field.
私たちは正確な位置と新鮮な地図を国民の皆様に届けることを使命として全国の地表の動きを監視しています。全国の広いエリアを効率的に監視するには衛星からの観測は欠かせない。
Exactly. Ultrasound kind of works like that. Ultrasound is not only used on that obviously the body and during the pregnancy and all, but also to know the cracks in between the walls. So those skyscrapers need proper maintenance, otherwise it will be catastrophic. And then there is cement, the concrete, there is some microscopic cracks or small cracks which you can't see from outside but have been formed inside. And those ultrasound scanners, they work on that principle only. They go and see if there is some crack inside the walls, and it will be able to see. We will get to know if it is there and if any maintenance is required for that. So in all those maintenance cases also the ultrasound is used. So yes, there are so many use cases of the whole spectrum of the light, right? The spectroscopy, the spectrometer, not only for the SAR but the spectrometer itself is kind of, a very, very advanced and very, very useful innovation that we have done. Because of that, we are able to figure out so many things, not only in microscopic level, but also on the galactic level also. That is one of those inventions which I love the most, which I would put on the list like of the top 10 inventions which changed the world, kind of like that. So yeah.
常に第一2号から長年継続してきた L バンドレーダーの観測データとも組み合わせることで、より長期的な変動も把握することができます。これにより地盤沈下調査などの測量にさらに活用できるようになると期待しています。国土地理院も第一4号のミッションパートナーとして JAXA さんとともに長年準備をしてきました。待望の打ち上げと思っています。第一4号からの国土の様子を捉えた画像が届くのを楽しみにしています。
はい。
So as video mentioned,
So we are T minus 40 minutes from the launch. Things are looking good, but I really hope they have the okay, let me check if we have a better feed in which we can see the rocket also. Let me check that. Give me a second.
we did in the Daichi-4, we can obtain a lot of information, so we can actually be promising to use them. And also, next one, so we'd like to ask more about the how we can use the data.
JAXA と森林総合研究所、茨城県、この3社で協定を結びまして、衛星森林管理技術の開発を行っております。JAXA から提供を受けたデータなんですけれども、本件の方でデータを森林クラウドで載せる作業を行っております。森林クラウドというのは県村とあと林業経営体、こういったところの間でですね、具体的には森林簿とか森林計画図、本県ですと伐採届出情報とか、あとは林地開発情報、その他空中写真とか森林情報をやり取りするためのシステムになっております。実際に伐採を行う際にですね、伐採を行うものは市町村の方に伐採届出を出すことになっております。届出がありましたら、市町村の担当者がですね、実際に現地を確認しに行って伐採届出通りに伐採が行われているかといったことを確認するんですけれども、昨今は市町村の人手不足ということで、現地確認にかなりの時間と労力と費やしてしまうということで、どうしてもそこはネックになっているというところがございます。ただ JAXA の方から提供を受けた衛星画像で伐採のデータがありますと、現地に行かなくてもその伐採が行われたかどうかといったところを確認できるといったところで、省力化につなげられるのではないかといったところが考えられます。第一2号と比較いたしまして、観測頻度が年に4回から年に20回ということと、あと解像度が6メーターから3メーターということで、非常に向上すると。これまで課題であった面積の誤差といったところもより精度が高いものになることが期待されます。精度が高くなることによってですね、実用的なものとなりまして、これまで現地に行っていたところが机上でも確認できますので、効率的な業務が行えるといったところが期待されます。私たちがやっているのは伐採とか森林管理についてですけれども、昨今かなりの気象災害もございますので、そういった災害等にもですね活用できるのではないかといったところが考えられるかと思います。他の分野でもいろいろ協力していければよりいいものがまたできるのかなというところで、ちょっと期待はしております。はい、
I think what they meant was they would be able to monitor those deforestation activities so that some actions can be taken accordingly. Not sure, it was not put in a good way, so we can't say much, but yeah.
example, like the building situation, like it's synced or and also used for the farming, crops, the cultivation of the farms, crops. There's this to detect the changes, and also in case of the plumbing or the if there's any or order link, so they can actually detect them. So they can actually identify many situations. And also, we would like to interview the project manager of DAICHI-4, Arikawa-san.
Yep, all the interviews and everything is going on, but where is the rocket? We wanted to see the rocket. Okay, T minus. Okay, she forgot to turn off her mic, right? And increase the volume of that. Okay. They did hear me. They did listen to me. Nice. Okay. All the evolution changes from ALOS-2 to ALOS-4. You might be wondering where is ALOS. Oh. Yeah, you might be wondering where is ALOS-3, right? If you would have looked into that presentation, we saw the ALOS-3 was actually, I think, had issues, if I'm not wrong. It was on board. Yeah, it was it was the first flight, the SC-22S. It was on that, and it did not deploy properly because the second stage did not start up. So it was, the FTS command was introduced and it was destroyed. So they had to make another satellite, ALOS-4, and then now they are up again on the H3 rocket. I'm hoping there is no as such catastrophic failure or something like that. Let's hope everything will go as per the plan. So we have only 33 minutes left and around 33 viewers watching. It would be very nice if you can, guys, if you are new to this channel, you can subscribe. Otherwise, you can share it with your friends and increase the watching, because we are about to come to the phase when the thing starts heating up, and we'll see more of the rocket footage also. So yes.
浸透していく、こういった衛星になることを期待しています。また衛星開発は JAXA だけでは成り知れず、多くのメーカーさんの技術を結集して成り立つものです。高い技術力を持つメーカーさんの技術をリスペクトし、共にタッグを組んで第一4号を完成させてきました。打ち上げ後の軌道上運用もメーカーさんと共に気を引き締めて確実に取り組みたいと思います。第一4号の開発を終え、いよいよ打ち上げに臨みます。打ち上がった後、軌道上でミッションを実現する安定な状態に持っていくまで気を抜くことができません。宇宙から得られた観測データを届け、皆さんが安全で安心できる社会を実現できるように努力していきます。第一4号が皆さんの日々の生活に役立つ日がもうすぐそこまで来ています。ぜひご期待ください。
So, Kotani-san, after you've seen this video, what do you think? So, ICA project manager is actually placing importance on the to work in the site. So, and he experienced in the satellite development field, and he became the project manager. And he was actually when in another interview. So, this satellite development, I can't remember, but he mentioned about the famous phase in Japanese movie. So, it's actually everything happening at the field.
You can actually see the rocket also in this feed.
We engage a lot of manufacturers.
If you can spot it, I can spot it. You can you spot the rocket? Not in this one, when it is when the camera moves to both of them, in that
training. So I think it's very. We are in the good shape to complete in the same boat, and also. Daichi number 4 has been supported by the ambassador and the artist Daichi Miura since the last version. He actually paid a visit to Tanegashima and he gave us a close-up look at the site just before the launch. Please enjoy the video.
第一シリーズ衛星のアンバサダーを務めさせていただいております。さあ、
Yes, we do have this kind of tradition also in Japan. Ambassador, the animations, and all those things.
ドキドキワクワクしております。さあ今回ですね、いろいろ紹介していただいたり、案内をしていただくということで、JAXA の方に来ていただいております。本日はよろしくお願いいたします。
第一4号サブマネージャーの感覚です。よろしくお願いします。
よろしくお願いします。
皆さん、
はい、
いよいよです。
そうですね。ちょっとドキドキワクワク。
今日は三浦さんの方に打ち上げを間近に迫った種子島宇宙センターの様子と、あと第一4号を宇宙に運ぶ H3 ロケット。はい。そして間もなく宇宙に旅立つ第一4号、それらの実機を対面いただいて、はい、打ち上げに向けてドキドキする気持ちとか、はい、ワクワクする気持ち高めていただければなと思います。
はい、とても楽しみにしてきたので、本日は
よろしくお願いします。
よろしくお願いいたします。
はい、ここからはロケット担当の川島にバトンタッチしたいと思います。はい、よろしくお願いします。
はい、よろしくお願いします。よろしくお願いします。よろしくお願いします。お願いします。
There is,
ではご案内します。
you know, these Japanese people, they have so, you know, the etiquettes and manners are just next level only. Yeah, you can see now the vehicle assembly building. Also see the rocket also. So you can see how big the rocket actually is. Literally you can see. This is the scale of the rocket. You can see. This is just the first tank, right? Yeah. And even the diameter of the rocket itself is kind of comparable to human. That's the thing. The two LE9 engines, the solid rocket boosters, the first is the hydrogen tank and then the oxygen tank is there. This is just next level.
But それってやっぱりロケットの打ち上げ能力を上げようと思うとできるだけやっぱ軽くして推進薬はいっぱい積んで燃料はいっぱい積んででも自分のロケットの重さ自体は軽くしたいんで
そうですよね。
そうですね。でそうするとタンクがもう大きくなってタンクばっかりになる。
That's true, Mars.
ロケットの重さに対してロケットそのものの重さは 10% で残り 90% は推進薬。
ああ、もう燃料だったり。
そう、燃料と酸化剤ほとんどそれです。
そうなんですね。
はい。
そうかそうか。でもなんかそれをちゃんとこう入れられる、それに耐えうる形で、こうできる限りこう軽くして、はい。でいわゆる秒速8キロでしたっけ？
そうですね。はい。第一宇宙速度って言うんですけど、はい。地球をぐるぐるぐるぐる回るのに必要なスピードです。
そこに投入していくその速度にしっかり上げていくためにそういういろんな技術が、はい、
はい、こちらが第一4号が搭載される場所になります。
This is the fairing. Look at that.
そうですね。はい。白い部分がフェアリングと呼ばれるところで、ロケット打ち上げるときに空気との摩擦とかで熱とか振動とかが加わるので、それから衛星を保護するためのカバーになります。57メーターありますけど、この形態だとこの57メーターの先端です。
You know what? When the rocket goes to space, they have the you know air ducts are there in the fairing before it lifts off. So there is actually air inside the fairing, and the temperature has to be controlled over there. So there's that. But the thing is, when the fairing pops up, it's in space, right? So there will be some pressure difference inside and outside. To balance it, there are some valves which are there to make sure whenever the pressure decreases outside, the valves make sure the pressure inside and outside remains the same, so that when the fairing pops up, there is no as such a blast or something like that which will cause any harm to the satellite or the second stage or the third stage or the upper stage or whatever you want to say. So yeah. Yes,
第一
exactly.
4号だ。で今第一4号は各種の試験を終えて、これから燃料充填とか、あとフェアリング。
This is the SAR satellite antenna, the white one, and they have to make this antenna very big to cover the actual swath and all. And this storage compatible satellites folded and all, literally they kind of require origami people here. Origami is the one in which you try to fold paper and make sure it's minimized. So sometimes they require those origami people to make sure the satellite itself is we are able to put that into the fairing. So that is one interesting fact.
衛星を経由して第一下ろしていくと、そういう2通りの方法があります。光衛星間通信システムルーカスというシステムを使って、第1、4号から静止衛星にレーザー光を使ってデータを送ると。これによってこれまでよりも非常に大量のデータを一度に送ることができると。でその静止衛星から地上にデータを下ろすところ、それが三浦さんの ALOS-PV で使っていただいた筑波宇宙センターの大きいアンテナです。
そうなんですよね。
ロケットの方は、狙った軌道に第1、4号を送り届けることで、打ち上げは終了しますけども、我々第1、4号はそこからが本番。
そうですよね。
初期運用というふうに我々呼んでいますけども、衛星に搭載された機器が正常に働くか機能するかということを確認するために、24時間体制でJAXA のみならずですね、関係会社の方々と筑波で監視していく、
いろいろ連携取りながら、
大きな作業の一つとしてこの太陽電池パドル、この展開、そして先ほど見ていただいた SAR の展開、もう一つ展開物があって、
そうですね、あれもちょっと気になってました。
AIS というアンテナになります。AIS というのは船舶自動識別装置というものでして、船の情報、船種であったりとか位置だったり速度だったり、そういった情報が船から出ているので、そういったデータを集めて SAR の観測データと融合させていろいろな情報を発信していくと、そのためにつけられています。こういう展開物を展開するっていう作業が我々待っているとなります。
楽しみですね。
そうですね、いろんな方法でデータを落として、そのデータが使われるということが我々にとっても嬉しいことなので。い
やーすごい。
はい、じゃあ皆さん、実機見ていただいて、実際どうでした？
いや、とっても感動しました。やっぱ圧倒的でしたし、やっぱり皆さんのたくさんの思いが詰まった第一4号なんだなっていうのをやっぱ間近で見てとても感動しました。
いや嬉しいですね。実は、この打ち上げ間近になった状態で、皆さんからたくさんの方々から応援メッセージいただいてます。
これはそれなんですね。
で当然ながら三浦さんのファンの方々からもたくさんいただいてます。今回そういったコメントでいただいた応援メッセージとか画像とか、こういう絵にしてみましたんで、ちょっとどんなことが書かれているか。
頑張れ。
I actually really like this thing. The way they are making sure the public is also involved. NASA also does it very well. ISRO, they don't care about the public at all. They play a different ball game altogether.
我々筑波の運用室に飾りたいなと思ってますけども、サインいただいていいですか？
いいんですか？僕はそんな
ぜひ
させていただいて。
じゃあよろしくお願いします。
じゃあちょっと書かせていただきます。
運用室に飾りたいと思います。
僕も応援させていただきます。
ぜひよろしくお願いします。
Nice.
じゃあ皆さん、
Amazing.
今日一日じっくり第一4号を見ていただきましたけど、どうでした？
そうですね、やっぱり第一4号、そして H3 ロケットをこう間近で見させていただいて、とても迫力にこう圧倒されましたし、こういよいよなんだなという思いがとてもこう高まりましたね。本当にこう皆さんが一丸となって今持っているこう全ての技術力と情熱と思いと愛みたいなものをこのプロジェクトに皆さんが本当に注ぎ込んで、その打ち上げそして運用されていくっていう、そこの一点に向けて曇りなくやっぱ皆さんが作業されている、そのプロジェクトをこう作り上げているっていうのを本当に僕はこう近くで見させていただいて肌身にこうとても感じているので、今日もたくさんその情熱を感じることができたというか感じましたし、いよいよついにこれが打ち上がっていくんだなっていう、もう本当にワクワクした思いでたくさん今包まれているので、このプロジェクトの一ファンとしてちょっと思いっきり力の限り応援したいなと、そういうふうに思いました。
ありがとうございます。これからも応援の方よろしくお願いします。
よろしくお願いします。
今日はありがとうございました。
ありがとうございました。
It reminded me of my days when I visited the factories and all. Can you spot the rocket in this frame? I can. Can you? Yeah, everything is okay with ISRO. They are just
number one, and also before the heat dry, so we receive many warm messages from Daichi-Mira's fan, and also we really thankful for that.
all right. Yeah, so nothing is going like wrong in ISRO. We will be having a launch soon in July, like in mid-July or something. But the thing is, yes, the launch cadence has been reduced a lot. They have been doing things internally. We'll see one of the launch. Most probably, yes. That will be an SSLV launch, so that would be amazing to see. To see how it will go, and yeah. Hey, we have the rocket footage.
H3 rocket is located, and currently we are broadcasting from Takesaki Observatory about 3 kilometers away from the launch site, and it's the radius 3 kilometers. We are not allowed to enter this range. The reason for this is actually the rockets carry a large amount of the fuel to generate the energy, so it can be the hazardous object after the filling of the fuel. So we can secure the range of the safety, and this is 3 kilometers. And the filling process was actually started from 3 a.m. Last night. So we restricted for the entry of any people. And also the weather for today is quite hot actually. It's very hot. I don't know if everyone can feel this, but we're all sweaty. And those who are watching from the site, please don't forget to drink water. And also we have a slight slim clouds, but no problem with the launch. And I think
why the quality is so bad here?
I think it's a very good weather for the launching. And
you can see now.
Also,
yeah, now you can see. This is the rocket, guys. This is the rocket.
Of H3 rockets, wind speed is limited to be less than 20 meters per second, and also the
finally some
is
views.
Limited to 20
You can see the rocket, and now the rocket itself, the topping off is going on the upper stage and the below stage. So things are looking good on that case. You can actually see. The foam is kind of, there is some difference, right? And you can movable launcher 5. Okay, nice. You cannot see the engines over there and the SRBs, but because that's inside the pedestal. Here you can see in the fairing some electrical connection as well as the air conditioning is going on. So because that is needed. I recall one of those conversations with some of the officials, which they said, why is it necessary to make sure there is proper pressure and air inside, because the biggest reason is the vibrations and all which is produced during the launch of the rocket. Air cushions them, absorbs them a bit. So because of that, it will be able to, the satellite won't experience that much. That's what the reason which they gave. Not sure if that is the case or what else. We'll have to. I'll just figure out a little bit more on this.
Control center where various
Okay,
tasks
finally.
are performed
All right.
remotely in preparation for the launch.
Japan is living in 80s era, 90s era. Which era? Literally, man. They have. This is okay. I think the all government organization works in the same way, no matter from which country they are. You can see the NASA, they broadcast 720p footage. Okay, this is the countdown sequence. So SRB ignition actually happens at minus 0.4 seconds. Nice. But yeah, NASA also broadcasts at 720p, and here JAXA, we are seeing what is happening here. And then there is ISRO also. To be honest, I like the ISRO's feed the most, because we are able to see all those datas, and the qualities also they have improved now. And the only issue is that they show the people's faces rather than the data most of the time. But yeah, I can't complain that much. So at least we are seeing those data, right? That is important. What I think is why they have ISRO has such a big, good quality on this is because they have a proper broadcaster, DD National, which is the government broadcaster. So because of that, they are able to make sure that all the quality is fine.
Yeah, and also we are connected to here. This is a range control center, or known as RCC. They monitor the status of the vehicle in flight, and they also work with LCC to make preparation for the launch. Yes, this is what we call range control center. Unlike LCC, the RCC tracks the direction in which the rocket will fly after launch, and also we are having ground stations along the trajectory. By moving the antenna,
smoking trays and all, yeah.
We check whether flight is on course. And if there's anything, we stop the flight. And since there are important decisions to be made, we have people who are responsible sitting at the back, who are responsible for launch and satellite.
So we are right now T minus 13 minutes from the launch. Everything is looking good. The weather looks green. We are not seeing any issues with the rocket, otherwise the countdown would have stopped. And range is also in control. We can see from the faces of these people, right? Because they are from the range control center. Nothing to worry about.
Also involving young people so that we can give experience to them. I'm no longer young, but Mimura-san, you are young. So ever since the flight number 1, you experience a lot. Are you not? Well, yes, I was able to see a landscape where I won't be able to see unless I come here. So we are now approaching the time for launch. So we would like to show you the video of ALOS-4 and H3 third vehicle up to today.
Shipment. Okay, this is nice. Get to see something. So this is how the rockets are transported, guys, through the containers, the shipping containers, always to the rescue, no matter what. These rockets are actually developed by the Mitsubishi Heavy Industries. From ship transportation now to the land transportation, you can see how they are made. So after that, the satellite delivery happens, the testing and all those clean room things, they do it. You can see it. And then obviously the cranes comes into picture, making sure all the stacking is done properly. This is the interstage. Now those stacks are coming in. This is the SRBs. Now it will be placed also. You can see that. And you can also see those decouplers. Yeah, right. Ejectors, which will eject the SRB after they have been burnt off. Those small SRBs there. Now this is the satellite being hosted on the payload adapter. Now the fairing is being pulled down and attached to the payload adapter. This is you can see the temperature control and all is happening here also. Wow, never knew that. So that orange color pipe was actually the air duct, and now they are actually putting it inside of stacking up above the upper stage. Now finally pushing it to since that's a mobile launch pad, it's pushing it down to the launch pad and launching in another 10 minutes from now. Second most beautiful, I would say. What's your first then? Yes, it's one of the most beautiful sights. Yes, very true.
X plus 5 minutes 11 seconds, the first and second stage separation. And at X plus 5 minutes 24 seconds, the second engine ignition starts. The launch vehicle will continue its flight, and ALOS-4 will be separated at about X plus 16 minutes 45 seconds.
Wow, nice. And you can see the gas thrusters. It will make sure the rocket second stage orientation is changed. This looks
Approximately 1
so
hour
real.
and 30 minutes after ALOS-4 separation, the second stage engine will make a controlled descent into the Indian Ocean.
Making sure no debris is left, right? There should be actually a rule, in my opinion. A rule which states that you need to have a propellant on board on all the satellites and the rockets, so that it can be deorbited once the life ends. So T-8 minutes 38 seconds from the launch.
Vehicle number 3 is just around the corner. From here, we will keep an eye on the live video feed from the launch site and the live audio feed from RCC and the General Command Center.
Finally, we can see one of these over there, Birdie, right? 8 minutes 11 seconds from the launch. Now we are hearing the mission control. If I can show you just a second.
480
打ち上げ8分前です。現在各系ともロケット打ち上げの最終作業を行っています。また警戒区域の安全は確認されています。
It is 8 minutes to launch. All systems are now in their final operations. The restricted area has been vacated and cleared.
T-7 minutes from the launch.
440 430 420
安全系準備完了。
Range safety system is go.
408、407、406、
車上系準備完了。
404、
Range system is go.
402、401、
Things are looking good. Everything is go for the launch. We are T minus 6 minutes 30 seconds remaining. Everything is looking great.
390、
We are hoping that this launch will be successful. This is the ALOS-4 mission which is going to the space. ALOS-3 was on the H3 rocket itself, but it was not successful. Now finally we are on the
370、
Japanese rockets, H3 rocket, the newly launched rocket. Hey, Anani Moose, welcome to the stream. Agnimandal, what's on board again? It's a satellite which is going to the sun synchronous orbit.
現在車上の天候は曇り、気温摂氏 29.1 度、南南西の風、毎秒 8.2 メートルです。
It's 6 minutes to launch. The current weather at the launch site is cloudy. Temperature is 29.1 degrees Celsius. Wind is 8.2 meter per second from the south-southwest. The weather is to go. The currently there is no constraint for launch.
Okay, there is no constraint from the launch. Everything is looking good.
12時6分42秒です。
Today's scheduled liftoff time is 12:42 seconds p.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300、99、98、97、96、95、
打ち上げ5分前です。
93、
It's 5 minutes to launch.
91、
5 minutes remaining. Oh, thank you so much, Michael Jeffrey, for upgrading your membership to engineer.
83、82、
I'm telling you, there are
208、
something which is coming up. Once the launch happens, I'll tell you, which will benefit all the members too. So thank you so much. Really appreciate it, man. All the contributions and everything. I make sure I totally improve on what I do right now. So all those little contributions really help me. So thank you so much, Michael. So right now I hope you can see the captions also, right? And able to figure out what they are saying in the Japanese. So I hope that would be beneficial for you guys. All right. And guys, whosoever has not subscribed to this channel, please do it, because many things are coming up very soon, which is very exciting. All right.
H3 is now operated under the command of Takesaki Launch Control Center.
21、220、
T minus 3 minutes 30 seconds remaining for the launch. Everything is looking good. So to recap, this launch is the first operational launch of the H3 rocket, in which this rocket is very unique because this is all right. This is the world's first rocket in which the expander cycle is being used in the first stage, because expander cycle is one cycle in which the gas generator or the pre-burner is not there. The fuel is heated and directly fed to the turbines. So you have a limit on how much thrust you can generate from it. But somehow they have figured out that, and the rocket is on the pad. First operational flight of H3 is on the pad. Talking about the satellite is the ALOS-4, which is nothing but a SAR satellite going to measure and scan the surface, as well as it will support the sailors and the fishermen in the ocean. So there's that. And yeah, enjoy the launch. T minus 2 minutes 20 seconds remaining. Everything is looking good. It's a sun synchronous yeah, it's an imaging satellite. Yes, you are right. T minus 2 minutes remaining. It's happening, guys. If you just give your best wishes by liking this stream, and let's hope this will be a successful launch. I'm really excited. Let's see what happens.
Pressurization process of a second stage liquid oxygen has been initiated.
Nice.
89、90、81、79、78、79、77、78、79、80、81、72、73、74、75、76、72、71、70、69、68、
T minus 67 seconds remaining. This is happening, guys. All right.
1 minute to launch.
T minus 55 seconds remaining. And this is finally happening, guys. Tanks have been pressurized. Things are looking good.
Flame deflector cooling is initiated.
Engine cooling is initiated. T minus 30 seconds remaining. Hit that like button and give your best wishes to this rocket.
The launch pad is activated.
T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9,
Hydrogen purge igniter on.
4, 3, 2, 1. Ignition and lift off. Look at that go. Whoa.
H3 ロケット3号機は2024年7月1日12時6分42秒に種子島宇宙センターから打ち上げられました。
We have a successful liftoff of H3
Look
launch
at that.
flight number 3
Look
from
at
JAXA
that.
Tanegashima Space Center at 12:42 p.m. on July 1st, 2024 Japan Standard Time.
You can hear everything is looking fine. It's looking good. Don't you worry about all those falling pieces. Don't you worry about them at all. Everything is looking as per the plan. Kinda looks animated though. But yeah, it's all about the exposure. The cameraman has to do its job properly. SRB separation is about to happen very soon. Please decrease your exposure, man. Yeah. And we have SRB separation done and dusted. Oh no. Wait. Felt like that. I think it has been separated. Everything is looking fine. Yes, that was the SRB separation only. They did not announce it. But yeah, that was the SRB separation. Now the LE9 engines are working. The two LE9 engines are there. And okay, now the SRB separation have happened. This is the first time I am also looking at its mission profile. So there might be some here and there. Payload fairing separation is coming very soon. So the SRB separations is done successfully. The issue with this rocket, which happened in the previous flight, the previous to previous flight, was the second stage. First stage performed as well. This time they are testing the throttling of the engines though. So in this phase they are testing the throttling, whether they are able to. Everything is nominal. So this time they are throttling down the engine so that they can make sure at the max Q it's fine, and the payload fairing separation it's going as per the plan. So they will be throttling down to 63%, but it can go down to 66% also, but this time they are going to 63%. Fairing separation coming up very soon now. You can see the the trajectory, how it looks like. It went to horizontal direction and then it started curving, right? And started curving in when
Separation was successful. Yes.
Yeah.
Altitude and speed, I think those are on course.
That was
And
cute.
the display here is the real-time CG image that we are getting information from the satellite on real time. Flight indicator for public is a name. So what we call this is H3 FIP. This is a simulation images. You see the rocket in the center indicated in circle.
So they are going to sun synchronous orbit.
And from
Wow,
Tanegashima,
first time
you
I
see
noticed this also.
trajectory of a launch.
They're going to sun synchronous orbit, but they launched eastwards, and then they are made the maneuver to go into that sun synchronous orbit. This is I think this is obviously is done to make sure the small islands which might be there in the way of the rocket, if they would have launched it in this direction directly, that would not be possible. So that's why they had to do this maneuver, and because of this maneuver they lost a lot of delta V also. But public safety is the utmost important, so yeah. ISRO also does something like they do a dog leg maneuver to make sure they are not having that issues. It's not that curvy, but still it is there. First stage engine cutoff completed. Now second stage engine started.
Right. We see second stage engine ignition. It really makes us quite nervous. Now, until second engine cutoff or ALOS-4 separation, we have some time. So let us explain to you using this. Now, second stage engine ignition started, and 324 kilometers in altitude was the expectation, and 12,600 kilometers per hour was the expected speed. So let me calculate. Oh well, we see speed coming down again.
Uh-oh. No.
Let's
no.
watch the FIP for some time.
No. Again, they had issues with second
But
stage.
anyway, if the engine is being combusted, the acceleration should happen.
We'll need to see whether it has ignition happened.
the
See,
left-hand side,
velocity
we
can
see
come
some
down.
shaking.
That is not a problem. Velocity can come down, but you can see the now it's fine. It's fine, guys. It's fine. Nothing has happened. It is working as per the expectation. So yes, the velocity can come down because what happens is when it all depends on the.
7 minutes into flight.
はい。あ、なんか予定通り。
Well, I guess everything is on course and normal. Expected altitude going to be after this. After the well, we saw the second stage engine ignition, no problem. So,
Okay.
well,
He made
probably
us
the
all
leader I was
nervous.
watching was different from the one that they are watching. Anyway, we are smoothly making flight.
Is about 530 kilometers. Velocity is about 3.5
No,
kilometers per
data
second.
transmission issue. The velocity can decrease when you move from the first stage to the second stage because the thrust decreases rapidly. So sometimes when you are climbing up, you are not getting that speed. But once the engine picks up its speed and the thrust increases, so At that time, it started increasing.
So as broadcast indicated, flight is on course. Thank you.
So we'd like to recap our situation. So this launch is, we thought that it's going very straight in the sky, but actually it seems like it's tilted and with the curve. So the satellite is actually going around the Earth. So it has a large speed to go around the Earth. Of course, not to drop to the Earth. So the satellite is to come to the orbit, so we need to have the acceleration to do that, and so we need to put in the orbit. So if we actually go straight, then we cannot get into the orbit. So we can have the rocket to be tilted and to put in the process.
He just explained sun synchronous orbit, right?
So
we all know that.
600 of the altitude, it's increasing. Of course, we shouldn't be really failing, but so for the H3 characteristics, there is a high liability. And so this liability means, to be specific, how are you securing
look at that.
That is a good question. So as mentioned in the explanation before, so I mentioned about H3, so we mentioned about high liability. So that is, so H2A or H2B, of course, we learned from them and from the designing perspective. So for example, like let's say that one equipment is actually fail one time in 10 times, and so then the actual situation from the design perspective is different.
Okay. Nice.
So from the design, this H3, the possibility of the failure, we actually trying to minimize that, and also we have the redundancy and also the reliable design that we.
We can see the velocity increasing rapidly now, very rapidly. The thrust is taking up because you can see the altitude is not increasing that much. It has reached its apogee, kind of like that, you know, near to the apogee right now. But the apogee can change because it's thrusting right now, so we never know. But right now, kind of it is near the apogee.
The high liability design that we worked on, so this is a third one that we worked on. So the satellite that can be mounted on the rocket, so we need to have the safety and the reliable rocket. We need to have more experiences. So that's what we want to do in the future. So we want to be successful with the launch, and we need to gain the trust from people.
I think
and
it is.
Of course, we can rely on the design, but also we can accumulate the experiences. And as you mentioned about the brand, so we want to establish the brand.
It is going towards that part. That's what it looks like. So T plus 11 minutes 41 seconds. So you can see at T plus 60 minutes 24 seconds, I think the next event will happen. So right now 17,300 kilometers per hour is the speed, 695 kilometers is the altitude. It will reach to around 25,000 kilometer per hour most probably.
So 4 minutes more, and the second stage will be cut off, and also the first stage will be separated. Those are the events that we are waiting for.
You can see the second stage ignition number 2 also.
It's in nominal.
But that is after the separation of the satellites.
The
We are
combustion
right.
of the second stage engine, attitude control, and trajectories are all nominal. The
Everything is
H3
good.
flight is on course. Current altitude is about 619 kilometers. Velocity is about 5 kilometers per second.
Great. So yeah, the second
I feel
stage.
very comfortable if.
Second stage ignition number 2 is there because it has to re-enter the atmosphere, so it decreases its speed at that point of time. Look at that kilometers per hour increasing. Okay, you can't see that.
second, 7.5 or 6 that accelerate.
Sorry, my bad.
Right now you see 20,000 per hour. So I think 27,000 that needs to be accelerated. So otherwise, so the satellite needs to maintain themselves to use their fuel. So they need to control themselves. So how the satellite can save their energy is something that it's so the rocket, how the rocket can support the satellite is very important role.
ALOS-4.
Much better.
ALOS-4, DAICHI-4, the satellites. As you saw in the video, the width of observation expansion was very much of the strength. Even if you rotate around the Earth same time, if you have a wider range of observation, you can gather more information. So LSAR, developed by Mitsubishi, enables that to happen. So we have a very high expectation and looking forward that. So I guess ALOS-4 is going to be utilized for various many applications. The radar satellites are being launched by private sectors one after another. As I introduced earlier, agriculture application is one way to use satellites. And not only disaster situation, but also our day-to-day life will be supported by radar satellites. So we have a very high expectation.
15 minutes into flight.
Yeah, it's above. I think it will. It's above New Zealand and Australia. Going that way.
1.5 minutes to go.
1.5 minutes
for
since
the second engine number 1 cut off, then followed by ALOS-4 separation.
こういう打ち上げもですね。
The launch is being done by Japanese private sector companies, including Japanese companies.
25, 26,000 kilometers an hour.
秒速約 6.9 km です。
The combustion of the second stage engine, attitude control, and the trajectories are all nominal. The 83 flight is on course. Current altitude is about 620 kilometers. Velocity is about 6.9 kilometers per
Altitude
second.
is decreasing. You can see that, right?
と言ってる間に。
So, soon to cut off the second engine ignition number 1.
And we have a cutoff. 27,490 kilometers per hour.
Well, there will be a separation of ALOS-4 very soon.
Velocity is still increasing because it's going down.
第一4号分離
And we have separation confirmed. This is the best part. See those rejoiced faces.
Yes, ALOS-4 separation was confirmed.
This translator is
Yes, very safely. So relieved. ALOS-4
He's kinda cute.
separation.
voice.
We were able to put the ALOS-4 onto the orbit.
Happy to see them happy also. Previously they were not when it failed.
So we could be successful. Please, we are pleased to announce that the successful launch of DAICHI-4. I'm sorry, I was too excited and I couldn't really talk. But so I'm sorry. In the middle, I was actually concerned. But so I'm very happy. So this DAICHI-4 is actually could launch the real satellite. So we could actually demonstrate that that's possible, and that is very significant. And also, as Okada, project manager, last time mentioned, so he mentioned that this is the start of the new life, and this we just started the walk. So we just step forward by being able to do this. And also, we will have a lot of launches. So maybe those who support will be very busy because we would have a lot of launches. So I think you will be very busy, and I'll keep you busy. And also, I know that it's very difficult to come to this site, but we would have more frequent launches, which means that you can actually have more occasion to come here, and maybe you can live here as well. If you are interested in Tanegashima, then please consider to live here. And also for the DAICHI-4,
Live here,
so what
okay.
would be the DAICHI-4 the plan? So right now in the orbit right now, so it's not something that we can use immediately. So first of all, we need to place the altitude, and also they need to use a solar panel to open up their power to save their energy, and also we need to confirm their performance. And after this, so the data. So once we obtain the data, so we need to do some reconfigurations, and also we need to adjust. So these works would require 6 months to do this. And as I mentioned, so to use for the disaster, and also the data that would be available after 6 months, I believe. So this start of the at scale, it would actually require a little bit more time, so we need to be patient. So from DAICHI-4, so the first data would be, we are very looking forward from the first page. And so the results of the second stage controlled re-entry of the H3 launch vehicle and the operation status of the DAICHI-4 will be announced at the post-launch press conference today. And the press conference will be streamed live on the JAXA YouTube channel as well. Please visit JAXA's official website and the social media. So this is actually very successful. So we already start the number 4 as well. So we would like to do another launch for future. So I'd like to have your support and encouragement. And H3 rocket and Daiichi number 4, we would like to look forward to the future of them. And thank you very much all for your watching our live stream. Thank you very much.
Bye bye. Bye bye. This is nice. I love their tradition though. They're cultured people, right? This is still left. Deployment of all these things. Nice. Many questions are there, right? And this also happened yesterday. For the people who don't know, this is a static fire. Okay, this is a static fire. You can see what happened to the static fire. That's catastrophic, not static. Literally, static fire and the rocket lifted off. Is it an achievement or a what? That too a very stable liftoff. And then a big boom after that. See? But yeah, these things happen, although I'm not sure why the hold down clamps did not work in this thing. Okay, whatever. So we had where is it? Someone posted it or what? No one posted this one. JAXA might have something about it. Has he? Okay, Firefly is also about to go. Okay, when is it? Tomorrow? 9:03 p.m. tomorrow. Yes, tomorrow. I'll stream this also. Don't worry about it. I'll stream it. Someone might have. Yeah, finally. Thank you. Okay. And this is another view or what? Yeah, this is another view. And this is a better view. This is much better than what we got in the actual live stream. They are incredibly lucky it shut down when it did. Yeah. 1 in a billion test. Sorry. So the rocket lifted off, the H3 rocket lifted off, as you can see. It was a beautiful liftoff, and finally the first operational flight of the H3 rocket completed successfully. We had a bit of a hiccup in between, that too because of the translator. She might have had some other info or what. She was saying something like that. She was looking at some other screen. But yeah, so nothing to worry about. Sometimes this happens. The velocity decreases when it is trying to go up. What happens is, like, when velocity decreases, it actually, I'm not, the velocity itself is what velocity? Is it a horizontal velocity or is it the vector product of the velocity, right? But sometimes it just goes up and don't go in the horizontal direction, and that time it does not record the velocity as increasing, right, if it is measuring the horizontal velocity. So yeah, so that is the case. That is the reason why sometimes in KSP also, if you have played, the velocity decreases even if you are accelerating, because you are climbing up. You are making sure your energy, whatever you are supplying to it, it's going to the vertical velocity. So yeah, no issues with the rocket. Everything went as per the plan. So the world's first expander cycle first stage engine had a successful operational flight, and from now on it will be used as the workhorse of the JAXA to support many commercial launches as well as other scientific launches, if any. So there is it. Hey, thank you so much. Hello from Japan. I hope you had a great day. It was a successful launch, and yes, this is the second most beautiful site, as Jennifer said, right? For me, it's the most beautiful one, and the second one comes the New Zealand one. I can understand why New Zealand one is your favorite. Not sure whether you have visited that site or not, but yeah, you are from New Zealand, so you will like that, right? But yeah, so I think that should be it. What all things are coming up. We don't have any spaceflight update as such in these days. Yeah, this was the one. Which was the Tianlong 3 first stage static fire, which went horribly wrong, which you can see. It was not supposed to lift off. It was just a static fire, but see, because of that, they did not even have a FTS system installed, because it was supposed to be a static fire. Why do you need a FTS system when you are having a static fire? Because you are on the ground, you can control everything, right? You need an escape if you are having a crew over there, pad abort, that's what we call it. But that's why you couldn't see it, any FTS system got activated in this one, because obviously no one even in their weirdest dream would have thought that a static fire would mean a rocket actually lifting off from the pad, and then everything just destroyed. They were supposed to demonstrate an orbital flight in this year itself, but their launch pad and everything, those supporting infrastructure would have been destroyed, totally destroyed with this unplanned flight. So they'll have to reconstruct all that and need to file in for that. I'm not sure what is there in China though. Like we have FA in US. In India we have this in space. Yeah, we have this in space which makes sure all these things are in control. Not sure what is there in China. I will not be surprised if there is no as such thing. But yeah, people actually don't really, in China we have seen so many boosters actually going to the crowded areas, but people display that as a bad image. But what I personally think, yes, that is something which they need to be responsible for and all that thing, but they are doing their this job. I mean, the scientists are doing their job. I'm not sure about the local authorities and all. The evacuation and all those things is the responsibility of the local authorities. That's what they are not doing. Talking about the scientists and engineers, they are making sure they can maneuver the first stage which they are dropping in nearby villages to a safety, because they have tested those balloon, what is that, some parachute on the first stage to maneuver it in to safety. So they're all testing that so that these kind of booster dropping down on houses and all does not happen. But yeah, that is the case. And mostly this happened because there are so many launch sites which are there on the land. Now they are constructing, and they have already have one active launch site on the island, the Wencheng island. So many of the launches will be moving there, so we will not be seeing such things happening in future. All right, so we have the Firefly launch tomorrow. Let me see. Yep, tomorrow Firefly launch at 9:33 a.m. for me. I will stream it again, and we also have 2 launches from China, but we won't be having a launch stream for that for sure. We have a Turksat launch on July 9, and then Ariane 6 maiden flight is go for the launch on July 9. That is something. I will surely stream this one. Don't worry about it. Ariane 6 is going to launch, right? That's something. Okay. And then we'll most probably be having a SSLV launch on July 15. So yeah. Cool. So I think that should be it from my side. If you have some questions, you can ask me. Otherwise, we can end this stream. And I'll have to go for the work also now. So there's that. So thank you so much for tuning in. I hope you really liked the stream. If you did, give it a thumbs up. And before going, I really forgot. There is something coming up. Very soon on this channel. I will just leave it here. There's something coming up. Okay. So do tune in for that. Things are going on in the background, and that's why I said just keep supporting me. I'll keep delivering good content for you. So just wait for it. It'll be coming up very soon. Something is there, right? Try to guess at what is this? Chill pepper in a hot box? Nah. Something related to rockets only. All right, we'll do it. Don't worry. Just wait for it. Very soon it will be launched. You will get to know what is this thing. Cool. Thank you so much for tuning in. I hope you had a great time, and until then, this is Piyanshu Rohila. You just saw Rocket Gyan. Stay safe, stay healthy, and